Hi, dear children. Today we are going to start our new chapter, chapter 6 in your NCERT book, triangles. Triangles. The lower classes already you studied about triangles. Ninth class also very detailed. Already you have studied it. Triangles. What is a triangle? You know, three sides and three angles. Okay. Here we are going to study similar figures at first. Similar figures. Similar and congruent. Both are uh, two basic names of geometry. Similar means, suppose this is a triangle, this is another triangle, this is a small triangle, this is a bigger, larger triangle compared to this triangle. Okay, the angles are same, suppose. This angle is same, this will be same, this will be same. But shape is different. Shape is same, but size is different. This is a small size, this is a bigger size. So we can say that these two figures are similar. These two figures are similar figures or similar triangles. Congruent triangle means in similar triangles, the angles are same, but the sides are proportionate. Sides are proportionate. For example, this is ABC. This is suppose PQR. Proportionate means AB by same side. PQ equal to BC by QR equal to AC by PR. AB, the ratio between AB and PQ is same as BC and QR is same as AC and PR. But the angles are same, equal. Then only we can say that they are similar triangles. Congruent triangle means there is same size also. That means if we put this triangle on this triangle, it will overlap. Then we can say that it is a congruent triangles. Okay. All congruent triangles are similar triangles, but all similar triangles are not congruent. Two figures having the same shape, but not necessarily the same size. There is similar figures. All congruent figures are similar, but similar figures need not be congruent. About polygons, two polygons are similar if their corresponding angles are equal and corresponding sides are proportional. Any polygon, here we are taking only triangles. Similarly, it can be quadrilateral, it can be any polygon, etc. Okay, two polygons are similar if their corresponding angles are equal and corresponding sides are proportional. These two figures are called similar figures. In similar triangles, the angles will be always equal. If this is 30 degree or this is suppose 30 degree, this is also 30 degree. And suppose this is 60 degree, this is also 60 degree. And suppose this is 90 degree, this is also 90 degree. Okay. This is the reason. This is the explanation of similar figures. Okay. Two polygons of the same number of sides are similar if their corresponding angles are equal. For any similar figures in similar polygons, their corresponding angles are equal, their corresponding sides are in the same ratio or same proportion. Already we discussed it, the first page. Okay. So this part is very important. Similarity of polygons. Two polygons of the same number of sides. For example, this is a square, and this is also a square. These two figures are similar figures because all angles, that is 90 degree, 90 degree, 90 degree. Okay, these two squares are similar. Angles are equal, sides are proportional. Okay. Circles are also, circle is not a polygon. Circles are also similar. Circles are also similar. Okay, right? So similarly, two triangles are said to be similar if their corresponding angles are equal, but corresponding sides are proportional. Okay. Then all circles are dash in brackets similar and congruent. What is the answer? All circles are similar. All circles are similar. All circles are similar. All squares are dash. All squares are dash in bracket similar congruent. All squares are similar. All squares are similar. Okay. All dash triangles are dash triangles are all dash triangles are similar. All dash triangles are similar. In brackets, isosceles equilateral. Isosceles equilateral. What is the answer? All dash triangles are similar. What is the answer? Equilateral. All equilateral triangles are similar. All equilateral triangles are similar. Okay. Yes. Our next part. Basic proportionality theorem, or it is also known as the Thales theorem. It is a very, very important theorem in this chapter. Basic proportionality theorem, or short form is BPT. Short form is BPT, basic proportionality theorem. It is also known as Thales theorem. Thales theorem. The statement is, if a line is drawn parallel to one side of a triangle. Look here. Suppose this is a triangle. Triangle ABC. ABC. If a line drawn parallel to one side of the triangle and just draw a line parallel to BC. This is parallel to B. Suppose this is ABC, DE. Here, DE is parallel to BC in the figure. If a line drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. That means in this figure, AD by DB, AD by DB, that is automatically equal to AE by EC. AD by DB equal to AE by EC. This is called Thales theorem or BPT or basic proportionality theorem. The converse of this theorem is, if a line divides two sides of a triangle, if a line divides two sides of a triangle in the same ratio, then the line DE is parallel to BC. This is the converse of this theorem. This is very important, very, very important theorem from this chapter. Okay, basic proportionality theorem. The symbolic form is BPT, or it is also known as Thales theorem. Once again, what is Thales theorem? Consider the triangle ABC, and the line DE is parallel to BC. Then we can say that the Thales theorem states that then AD by DB is equal to AE by EC. That is very important, BPT. Okay. Next is problems we will do later. Next is criteria for similarity of triangles. There are four criteria for similarity of triangles. One is AAA criterion. AAA. That means angle, angle, angle. Suppose this is a triangle ABC. This is another triangle PQR. AAA criterion means here A is equal, suppose A is equal to P, B equal to Q, C equal to R. That means the three angles are same or equal. Then we can say that these two triangles are similar. That is AAA criterion. In two triangles, corresponding angles are equal. Then their corresponding sides are in the same ratio. That is automatically happens. If in two triangles, corresponding angles are equal. Corresponding angles means here angle A is equal to angle P, angle B equal to angle Q, angle C equal to angle R. Then automatically we can say that the sides AB, BC, CA proportional to PQ, QR and PR. That is automatically happened. That is called AAA criterion. AAA criterion. Angle, angle, angle. In a triangle, if in two triangles the corresponding angles are equal, then their corresponding sides are in the same ratio or proportion. Okay. The next is AA criterion. Next is angle, angle. If two angles of one triangle are respectively equal to two angles of the another triangle, then also the two triangles are similar. For example, if A equal to P, B equal to Q, then also we can say that the automatically third angle will be equal. Then we can say that the other angle, if two angles of one triangle are respectively equal to two angles of another triangle, then also the two triangles are similar. It is called AA criterion. Next is yes criterion. Side, side, side. That is, in two triangles, corresponding sides are proportional, then their corresponding angles are equal. For example, consider these two triangles if AB equal to PQ. If AB equal to PQ, BC equal to QR, AC equal to PR, then we can say that the corresponding angles, that means angle A equal to P, angle B equal to Q, angle C equal to R. This is called yes. That means side, side, side. If in two triangles, corresponding sides are proportional, then their corresponding angles are equal. That is yes criterion. Next is SAS. SAS. SAS means two sides and one angle. Side, angle, side. This angle is in between these two sides. For example, if we take AB and AC, then consider this angle A. That means in between these two sides. That is called SAS. If one angle of a triangle is equal to one angle of another triangle and the sides including these angles, that is very important. The sides including this angle, that means here it is AB and AC includes the angle A. These angles are proportional, then the triangles are similar. That is SAS criterion. If one angle of a triangle is equal to one angle of another triangle and the sides including these angles are proportional, then the triangles are similar. This is called SAS criterion. Okay, this is very important criterions. A stands for triple A, stands for angle, angle, angle. If in two triangles corresponding angles are equal, then their corresponding sides are proportional. A criterion. If two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. Then the side. If in two triangles corresponding sides are proportional, then automatically their corresponding angles are equal. Then last is SAS criterion, side, angle, side. That means the angle, these two sides includes this angle. If one angle of a triangle is equal to one angle of another triangle and the sides including these angles are proportional, then the triangles are similar. Okay. Scale factor, the ratio of the corresponding sides of two similar figures. Scale factor. It is called the ratio. Suppose this is a triangle, this is another triangle, this is ABC, suppose this is PQR. Scale factor means, for example, these two triangles are suppose similar triangles, then AB by PQ equal to BC by corresponding side QR equal to AC divided by PR. AC divided by PR. This is called scale factor. This ratio is called scale factor. Okay, that's only. Areas of similar triangles. Area. The ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. Suppose two triangles. One is ABC. Then another triangle is, this is suppose ABC. This is suppose PQR. And here ABC, the triangle ABC, similar. This is a symbol for similar. Similar to PQR. Triangle ABC similar to triangle PQR. Then area of ABC divided by area of PQR. Very important theorem. This is equal to AB by PQ whole square. Or this is also equal to BC by QR. BC by QR whole square. Or this is also equal to CA divided by CA divided by RP whole square. This is very important theorem on similar triangles. In similar triangles, this is the concept. Suppose ABC is similar to triangle PQR. Triangle ABC is similar to triangle PQR. Then ratio between the areas, that means area of triangle ABC divided by area of triangle PQR is equal to AB by PQ whole square or BC by QR whole square or CA by RP whole square. Very important theorem. Application of similar triangles that we will discuss later. Application side, so many questions are there. We will do these questions later. Then one more criterion, RHS similarity criterion. This is only for right triangles, RHS criterion. The hypotenuse and one side of one triangle. Look here, these are two triangles, right triangles, ABC, right triangle, and another right triangle, PQR, another right triangle. The hypotenuse and one side of the triangle are proportional. Here the hypotenuse AC, AC by PR, hypotenuse, and any one side, for example this side, AB by QP. AC and PR are the hypotenuse, and take any one of the corresponding sides, AB and PQ, AB by PQ, then automatically are proportional to the hypotenuse and the corresponding sides of the other triangle, then the two triangles are similar. In this case also, these two triangles are similar. This is called RHS similarity. This is used only in right triangles, RHS similarity. If in two right triangles, the hypotenuse and one side of one triangle are proportional to the hypotenuse and the corresponding side of other triangle, then also we can say that these two triangles are proportional. Automatically the third side is also proportional. Okay, this is the RHS similarity criterion. This is the important theory parts of this chapter. Okay, another question. So almost the theory parts completed. Okay. Question: state whether the following quadrilaterals are similar or not. These are two figures. The following figures are similar. For example, this is PQRS ABCD. 1.5 centimeter, 3 centimeter, 1.5 centimeter, 3 centimeter, 1.5 centimeter, 3 centimeter. Is these two triangles similar? No. Clearly, these two triangles are not similar. Here, the sides are proportional, but shape is different. Angle. This is a square, this is a rhombus. These two figures are not similar because the first figure is a rhombus, second figure is a square. These two figures are not similar. Okay. This definition is very important, similarity of polygon. Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. You always remember this definition. Then next is basic proportionality theorem. Already we have discussed it. Okay. I can give you another question. In figure, you write in figure. Figure ABC. Figure ABC. This is D. This is D. 1.5 centimeter. This is suppose 1 centimeter. This is 3 centimeter. This is 3 centimeter. Here it is given that DE parallel to BC. Also given in the question, DE parallel to BC. Find EC. Find EC. Find EC. How we can find out EC? Use basic proportionality theorem or Thales theorem. What is basic proportionality theorem? If the line D is parallel to the side BC of this triangle, then using BPT, basic proportionality theorem, AD by DB equal to AE divided by EC. Here we have to find out CE or EC. What is AD? 1.5 divided by 3 dB equal to what is AE? 1 by EC. We have to find out EC. So cross multiplying, EC is equal to 3 divided by 1.5. EC is equal to 3 divided by 1.5. So this is equal to how much? 30 divided by 15, that is 2 centimeter. EC is equal to 2 centimeter. That is the answer. Another question. Another question. Another question. Consider the triangle ABC. This is triangle ABC. This is triangle ABC. Also given D. This is D. This is D. And also given this is 7.2 centimeter. 7.2 centimeter AE. This is 1.8 centimeter. And this is 5.4 centimeter. 5.4 centimeter. Also given that DE parallel to BC. DE parallel to BC. Find AD. Find AD. This is the question. Since DE is parallel to BC, we can apply BPT, basic proportionality theorem. Okay. What is basic proportionality theorem? Apply basic proportionality theorem, we get AD by DB equal to AE divided by EC. We have to find out AD. So AD divided by what is DB? 7.2. DB 7.2 equal to what is AE? 1.8 divided by what is CC? 5.4. Therefore, AD is equal to cross multiplication 1.8 into 7.2 divided by 5.4. 1.8 into 7.2 divided by 5.4. That is, we can simplify this as this can be, you can simplify this. You can use any method, no problem. You will get the final answer is 2.4. 1.8 into 7.2 divided by 5.4. That is equal to 2.4. How we can solve it? I can give you no problem. How we can solve this simple method? Use the simple method. AD is equal to 1.8 is 18 by 10 into 72 by 10 divided by 54 by 10. No problem. You can use this method also. So this is equal to 18 by 10 into 72 by 10 into 10 by 54. 10 by 54. Okay. 110 directly can be cancelled. 110 directly can be cancelled. Then 18 into 72 divided by 10 into 54. Again you can simplify. That is 18 into 72. Simplify with the 6. 6 into 3, 18. 12 into, not 12, 54 it is 54. 10 into 54. 9 times. Then simplify this. You can simplify this 18 into 72. But this is, you can simplify with 18. By 10 into 72 by 54. Very simple question. You will get 24 by 10. That is 2.4. 2.4 centimeter. 2.4 centimeter. Okay. Next question. Another question. If E and F, are points, if E and F are points on the sides PQ and PR, E and F are points on the sides PQ and PR respectively of a triangle PQR. Of a triangle PQR. Of a triangle PQR. State whether for each of the following cases, state whether EF parallel to QR. EF parallel to QR. First question. PE equal to 3.9 centimeter. PE equal to 3.9 centimeter. EQ equal to 3 centimeter. PF equal to 3.7 6 centimeter and FR equal to 2.4 centimeter. 2.4 centimeter. This is our first question. So, first you draw a figure. Triangle PQR. This is triangle PQR. And also EF parallel to QR. EF parallel to QR. That is given in the question. What is PE? Here, as per BPT, basic proportionality theorem, PE divided by EQ is equal to PF divided by FR. That is 3.9 divided by EQ, 3. Find it. PF, 3.6 divided by 2.4. If it is equal, we can say that they are parallel. If it is not equal, they are not parallel. So, 3.9 by 3, that is 1.3. 1.3. 3.6 by 2.4. 3.6 by 2.4. 3.9 by 3. 3.9 by 3 is 1.3. 3.6 by 2.4 is 36 by 24. That is equal to 3 by 2. This is 1.3. This is 3 by 2 is 1.5. They are not equal. They are not equal. PE by EQ here. PE by EQ here. PE by EQ not equal to PF divided by FR. So, basic proportionality theorem is failed here. Therefore, we can say that EF is not parallel to QR. This is the answer. EF is not parallel to QR. This is the answer. Okay. And another question, using this same figure, one more question. Using the same figure, we can do one more question. Here given that PE equal to 4 centimeter, QE is equal to 4.5 centimeter, QE 4.5 centimeter, PF is equal to 8 centimeter, PF is 8 centimeter, RF is equal to RF is equal to 9 centimeter. PQR, okay. By using basic proportionality theorem from the figure, PE divided by EQ is equal to PF divided by FR. So we have to check using these figures. PE, left hand side, PE divided by EQ. P is 4 centimeter. 4 divided by EQ or QE, that is 4.5. 4 divided by 4.5, that is equal to 40 divided by 45. Cancelled with 5, that is equal to 8 by 9. Take it as 1. Then right hand side PF by FR. PF by FR. That is equal to 8 by 9. Yes, it is very clear they are equal from 1 and 2. From 1 and 2, PE divided by EQ equal to PF divided by FR. So, using basic proportionality theorem, we have EF parallel to QR. EF parallel to QR. This is the answer. And another question. And another question. You draw this figure. Just draw this figure. ABC, this is A, B, C, D, and this is M, N, L. In figure, given that if L, M parallel to CB, LM parallel to CB, and LN parallel to DC, LN parallel to DC, then prove that AM by AB, prove that AM by AB equal to AN by AD. AN by AD. This is the question. Okay, how we can prove it? Consider triangle ACB. Consider triangle proof. Consider triangle ACB. Consider triangle ACB. Here LM parallel to CB. Here LM parallel to CB. LM parallel to CB. Therefore, using basic proportionality theorem, AM by MB, AM by MB is equal. You apply basic proportionality theorem BPT. AM by MB is equal to AL divided by LC. AL divided by, consider this triangle, that is, apply basic proportionality theorem because LM parallel to CB. We can apply basic proportionality theorem. Take it as equation 1. Then again, consider triangle ACD. Second triangle, consider triangle ACD. Consider triangle ACD. In triangle ACD, LL parallel to DC. Again, apply basic proportionality theorem. AN divided by ND. Apply basic proportionality theorem. That is equal to AL by LC. Take it as equation 2. First you consider this triangle ABC, then second triangle. Apply in both triangles basic proportionality theorem. You will get two equations like this. From 1 and 2. Here, right hand side of both equations are equal. AL by LC, AL by LC. From 1 and 2. From 1 and 2 implies left hand sides are also equal. AM divided by MB equal to AN divided by ND from 1 and 2. Because the RHS of both equations are equal, then automatically LHS are equal. Therefore, I can write the remaining steps here. Take reciprocals. Take reciprocals. Take reciprocals. MB divided by AM is equal to ND divided by AN. You mention take reciprocals. Taking reciprocals. Add 1 on both sides. MB by AM plus 1 is equal to ND by AN plus 1. Take LCM. MB plus AM by AM is equal to ND plus AN by AN. From the figure, what is MB plus MB plus MB plus AM? MB plus AM. From the figure MB plus, what is MB plus AM? That is AB. That is, this is AM. That is AB by MB plus MB is AB by AM. ND plus AN. ND plus AN, that is AD. AD by AN. AB by AM is equal to AD by AN. Then again take reciprocals. Take reciprocals. AM divided by AB is equal to AN divided by AD. Take reciprocals on both sides. This is, we have to prove. Hence the proof. This is the proof. Taking reciprocals. This is the proof. This is the proof. Okay. We will do some more questions in the next class using the AAA criteria, SAS criteria, AA criteria. Okay, children. See you again next class. Thank you. Thank you. Today we are going to do some questions. Theory part almost completed. Also, we had done some more some questions also. In this section, we are doing some questions from this AA criterion, SSS criterion, SAS criterion, etc. Okay, let us do some question. First question: state which pair of triangles are similar. I can give you a question. This is the first figure. This is another figure. This is another figure. And this is triangle ABC. This is triangle PQR. And also given that angle A is 60 degree. Angle P, that is also 60 degree. Angle B, that is 80 degree. Angle Q, that is 80 degree. And also given that angle C 40 degree, angle R, that is 40 degree. We have to check whether these two triangles are similar or not. Okay. Let us examine the angles because the angles are given. First, we can examine the angles. Angle A equal to angle P, that is 60 degree for both of these two triangles. Similarly, angle B equal to angle Q equal to, that is 80 degree. Then angle C is equal to angle R is equal to 40 degree. Three angles are equal. So, using AAA criterion, we can say that these two triangles are similar. These two triangles are similar. Okay? Clear? Another question. I can give you another pair. I can give you another pair. The question is, this is one triangle, that is triangle ABC. Let us take triangle ABC. And it is the sides are given. What are the sides? 2, 3, 2.5. Also given that another triangle like this. Another triangle like this. PQR. This is P, this is Q, and this is R. And also given the sides 4, 5, 6. These are the sides given. Here the sides are given. The previous question, angles are given. So, what about sides? Is it proportional or not? Consider triangle ABC and triangle QRP. Consider triangle ABC, triangle QRP. That is 2 by 4, AB by QR, that is 2 by 4, 1 by 2. BC by RP, BC by RP. What is BC? 2.5. What is RP? RP is 5. That is 25 by 50, that is 1 by 2 again. Take AC by QP. AC by QP. What is AC? AC is equal to 3. What is QP? 6. That is 1 by 2. Look here, all the sides are proportional. AB by QR is equal to BC by RP is equal to AC by QP. Therefore, again, which criteria, what criteria is used here? Sides are proportional. That means yes, yes, yes criterion. Yes, yes, yes. Using yes, yes, yes criterion, we can say that these two triangles are similar. These two triangles are similar. Okay? And another question. Another question. Another pair. And another pair. Look here. Triangle MNL. MNL. Given as this is 2.5, this is 5, this is 70 degree. And also another triangle like this is a big triangle. Is a big triangle PQR. This is given as the triangle PQR, also given that PQ, that is 5, QR 10, and also this is 70 degree. 70 degree. Okay, this is the question. Consider triangle MNL. Consider triangle MNL and triangle MNL and triangle QMNL QPR. QPR. From the triangle, it is very clear that angle NM, angle NML, angle NML, that is equal to angle PQR, angle PQR. What about its sides? Two sides are given. What about its sides? ML by QR, ML by QR, that is 5 by 10, 1 by 2. Similarly, MN divided by PQ. What is MN? 2.5 by 5, 25 by 50. That is again 1 by 2. Two sides are proportional, one angle is equal. Two sides are proportional, one angle is equal. What criteria we can use here? SAS, using SAS, side angle side criteria. These two triangles are similar. These two triangles are similar using SAS similarity criterion. These two triangles are similar. Okay. I think do you understand this question? You understood this question? Okay. And another question. Yes, you write another question. In figure, triangle ODC, similar to triangle OBA, similar triangle OBA, angle BOC, that is 125 degree, angle BOC is equal to 125 degree, angle CDO, that is 70 degree. Find angle DOC, comma, angle DCO, comma, and angle OAB, and angle OAB. Figure is also given like this. This is the figure given. This is the figure given. This is the figure given. This is given as AC, and this is given as BD. This is O. Also given that this angle is 70 degree, and also this angle is 125 degree. This is the figure given, 125 degree. Okay, it's a very simple question, but previous question, board examination question. So from the figure it is very clear that angle DOC, what is angle DOC? Angle DOC, this is angle DOC, plus angle BOC, that is equal to 180 degree. Angle DOC plus angle BOC is equal to 180 degree. What is the reason? You mention the reason also. Linear pair, DOC and COD are linear pair. We have to find out angle DOC. So angle DOC plus what is angle BOC, that is given. Angle BOC is given in the figure, it is very clear. That is 125 degree equal to 180 degree. Therefore, angle DOC equal to 180 minus 125, that is 55 degree. 55 degree is the answer. 55 degree. Then next question, we have to find out DCO also. We have to find out DCO. Consider triangle DOC. Consider triangle DOC. Consider triangle DOC. Angle DOC plus angle DOC plus angle OCD plus angle CDO, that is 180 degree. That is 180 degree. That is, what is angle DOC? Angle DOC, that is 55 degree. Plus, what is angle OCD? Angle OCD, we have to find out DCO. OCD or DCO, that is, we have to find out OCD or DCO. That is DCO. Plus angle CDO. Angle CDO is 70. That is 180 degree. Therefore, angle DCO plus 55 plus 70, 125 degree, 180 degree. Angle DCO is equal to 180 minus 125 equal to, that is also 55 degree. That is also 55 degree. Then what is angle OAB? What is angle OAB? Here, angle DCO, this is 55 degree. This is 55 degree. Then what will be angle OAB? This angle. These are alternate interior angles. So this is 55 degree. Angle OAB will be also 55 degree. Angle OAB, that is also 55 degree. That is also 55 degree. Alternate interior angles. Okay, next question. Next question. Diagonals AC and BD. Diagonals AC and BD of a trapezium ABCD with AB parallel to DC, with AB parallel to DC, intersect each other at point O. Intersect each other at point O. Using a similarity criterion, for two triangles, show that OA by OC is equal to OB by OD. Okay. We can draw a figure like, suppose this is the trapezium ABCD. This is the trapezium ABCD. AB parallel to CD, that is given in the question. Also the diagonals. These are the two diagonals. Meet at O, that is given. Meet at O. Consider triangle OAB and triangle OCD. Consider triangle OAB and OCD. Angle OAB equal to angle OAB, that is equal to angle OCD. Angle OAB equal to angle OCD. What is the reason? Alternate interior angles. Alternate interior angles. Similarly, angle OBA. Similarly, angle OBA is equal to triangle ODC. Angle ODC. Angle OBA. This is angle OBA is equal to angle ODC. These two angles are equal. Reason? Same reason. Alternate interior angles. Alternate interior angles. Then triangle OAB similar to triangle OCD. What is the reason? Two sides are equal. Two sides of these two triangles are equal. Then automatically the third angle is also equal. What condition? AA criterion. Using AA criterion, these two triangles are similar. You write the reason. Using AA criterion, these two triangles are similar. Since these two triangles are similar, their sides are proportional. Therefore, OA by OC is equal to OB by OD. OA by OC is equal to OB by OD. What is the reason? The sides are proportional for a similar triangle. The corresponding sides are proportional for similar triangles. This is the answer. This is the answer. Okay. And another question. Another question. In figure, E is a point, capital E. Capital E. E is a point. E is a point on the side CB, on the side CB, produced of an isosceles triangle ABC. Produced of an isosceles triangle ABC with AB equal to AC. With AB equal to AC. If, full stop, if AD perpendicular to BC, AD perpendicular to BC and EF perpendicular to AC, EF perpendicular to AC, prove that triangle ABD similar to triangle ECF. Triangle ABD similar to triangle ECF. Triangle ABD similar to triangle ECF. Okay. Figure is also given. I can give you the figure also. Figure is also given. Figure is also given. This is an equilateral triangle. Suppose this is an equilateral, not equilateral, isosceles triangle, because in the question it is given that isosceles triangle only. This is an isosceles triangle ABC. And also given in the question, CB produced. CB produced means like this. This is the projection. CB produced to E. This is suppose E. And this is F. E is a point CB produced an isosceles triangle ABC with AB equal to AC, with AB equal to AC. If AD perpendicular to BC, this is AD. AD perpendicular to BC and EF perpendicular to AC. EF perpendicular to AC. This is the figure. This is the figure. Here we have to prove triangle ABD and triangle ECF. Triangle, this is triangle ABD, this is triangle ECF. We have to prove both are similar triangles. Both are similar triangles. Okay. Proof. Consider the triangles ABD and ECF. Consider the triangles. Consider triangles ABD. Consider triangles ABD and ECF. We have to prove these two triangles are similar. That is the question. So consider triangle ABD and ECF. Okay. In the figure, AB equal to AC. What is the reason? AB equal to AC. Because ABC is an isosceles triangle. BC is the base. In an isosceles triangle, the side AB and AC are equal. Two sides are equal. In an isosceles triangle, BC is the base. So AB equal to AC. That is given. Angle ACB is equal to angle ACB equal to angle ABC. What is the reason? Angle ACB is equal to angle ABC. What is the reason? Base angles of an isosceles triangles are equal in measure. Lower classes you have studied it. Base angles of isosceles triangles are equal. Therefore, angle ACB equal to angle ABC. This is the reason. Okay. Then angle ABC equal to angle ACB. Interchanging LHS and RHS. That's only. Okay. Angle ABD equal to angle. Angle ABD equal to angle. Angle ABD. That is equal to angle ECF. Angle ECF. What is angle ABD? This is angle ABD. What is angle ECF? This is angle ECF. What is the reason? Angle ABD is equal to angle ECF. What is the reason? Angle ABD is equal to angle ABD equal to angle ECF. This is angle ABD. This is angle ECF. These two triangles are perpendiculars and these angles are equal. Therefore, angle ADB is angle ABD is equal to angle ECF. Take it as equation 1. Take it as equation 1. Then also angle ADB. Then also angle ADB is equal to angle EFC. Both are 90 degree. Angle ADB is equal to angle EFC. That is given. That is given. 90 degree. That is given. Take it as equation 2. That is given in the question. They are each is equal to 90 degree. That is given in the question. That is from 1 and 2. That is from 1 and 2. That is from 1 and 2. this is 1, this is 2. The triangles, that is from 1 and 2, the triangles are similar using AA criterion, and two sides are proportional. Two sides are not proportional, two sides are equal. In triangles ABD, these two triangles are equal because each of them is equal to 90 degree, and angle ABD is same as angle ECF. So using 1 and 2, using AA criterion, both triangles are similar. Both triangles are similar. Okay. Another question. Another question. D is a point on the side BC of a triangle. D is a point on the side BC of a triangle ABC, such that angle ADC is equal to angle BAC. Angle ADC is equal to angle BAC. Show that CA square, CA square is equal to CB into CD. CB square is equal to CB into CD. Okay. D is a point on the side of BC of a triangle ABC. Figure is not given, but we can draw the figure. Suppose this is triangle ABC. And also given that D is a point on BC. Join this. D is a point on BC, that is given. Okay. Consider triangle BAC and ADC. Consider triangles BAC and triangle ADC. BAC, this is BAC, this is ADC. Okay, angle BAC is equal to angle ADC. Angle BAC is equal to angle ADC. What is the reason? That is given. That is given. Also, angle BCA, angle BCA is equal to angle DCA. Angle BCA. This is angle BCA. This is angle DCA. Common angle. Angle BCA is equal to angle DCA. That is common angle. So, therefore, triangle BAC similar to triangle ADC. What is the reason? Two angles of these two triangles are equal. So therefore, AA similarity criterion. These two triangles are similar. Since these two triangles are similar, their corresponding sides are proportional. That is CA by CD. What is CA? CA by CD equal to what? CB equal to CB by CA. Cross multiplying we will get. You cross multiply this. CA into CA, that is CA square is equal to CB into CD. This is the proof. CB into TD. This is the proof. Another question. A vertical pole of length. A vertical pole of length. A vertical pole of length 6 meter. 6 meter cast a shadow 4 meter long on the ground, and at the same time a tower casts a shadow 28 meter. A shadow 28 meter long. Find the height of the tower. Find the height of the tower. Okay. I can draw a figure. Suppose here is the sun. Here is the sun. This is the vertical pole of how much? 6 meter. 6 meter height. Vertical pole of 6 meter height. Automatically the shadow will be this side because this side is the sun. This is the shadow. This is the shadow 4 meter. This is length of the shadow. This is the vertical pole. This is ray of sun. This is ray of sun. This is pole. Length of the pole. This is, here it is shadow. This is shadow. That is given. Okay. This will be always 90 degree. Ray of sun. Okay. And one more condition. A tower. Suppose this is the tower. Here again sun is here. Here is the sun. This is the tower. This is the tower as per question. And length of the shadow, this side. This is 28 meter length of the side. This is ray of sun. Ray of sun. Shadow 28 meter long. This is tower. We have to find out the length of the tower. Okay, that is from the question. From the question. Consider triangle ABC and triangle. Suppose this we can take it as this is DEF. And first triangle we can take it as ABC. First triangle ABC. Okay. Consider triangles ABC and DEF. Consider triangles ABC and DEF. Consider triangle ABC and DEF. Angle B equal to angle E. Why? Each is equal to 90 degree. Angle B equal to angle E. That is equal to 90 degree. Each is equal to 90 degree. Similarly, angle A equal to angle D. Why? Because here the angle formed from the sun. Both are the same time. That is, angle A and D are equal. Angle A and D are equal. Shadows are cast at the same time. That is the reason. shadows are cast at the same time. So these two angles are equal because this angle formed from the sun, angles the same time also, the shadow are cast at the same time. So we can say that triangle ABC is similar to triangle DEF. Why? What is the reason? Because AA criterion, two angles are equal, then automatically third angle is equal. That is called AA criterion. Therefore, the corresponding sides are proportional. Corresponding sides means AB by DE. Therefore, AB by DE, AB by DE, AB by DE is equal to BC by EF. BC by EF. Corresponding sides are, since these two triangles are similar, then the corresponding sides are proportional. Corresponding sides are proportional. That is AB by DE equal to BC by EF. We have to find out D. What is AB? AB is 6 divided by D. That is the length. That is the length of the tower. What is BC? BC is 4. BC is 4 divided by what is EF? That is 28. EF is equal to 28. Then cross multiplying we will get 6, 28 into left hand side, 28, 4 by 4, that is equal to D. That is 4, 28, 7 times. That is D equal to 42 meters. D is equal to the length of the tower. D is equal to 42 meters. This is the answer. It is an application question, application problem from this chapter. Okay. So this session is completed right now. See you again next class with a new chapter. We will do more questions from this chapter as multiple choice question that will be on live. Okay. Almost the difficult questions from your NCERT book is completed right now. Thank you. Thank you all.